Hello, Caymans. Mr. Eicher here, coming at you to teach you lesson 1-6, chapter 1, section 6, about solving compound inequalities and solving absolute value inequalities. So if you haven't printed the page of notes for the notes 1-6, I encourage you to do that. So you have those handy, have something out to write with, have a calculator, and we will jump right in with compound inequalities. So a compound inequality is inequality. A compound inequality is two inequalities joined by the word and or the word or. So compound, the idea of being compound, is two things are joined together, compound inequality. So an and inequality is the intersection, and the special symbol in math for that is this upside down U here, intersection of the solution sets. And an or compound inequality is the union, or a capital U symbol, union of the solution sets. So if you want two things to be true at once, that's the intersection. If it's one or the other, then that's a union of the solution sets. So let's look at a few inequalities. This should be review. I believe interval notation might be a review for you as well, but it's always good to review, make sure everybody's on the same page. So we have x is greater than or equal to -1 on a number line. We would graph -1, and we have greater than -1, so we're going to go this way. I like to do the line above. Some people like to kind of shade in this line, and really either one's fine. But something to realize, since it's greater than or equal to, we won't have an open circle. An open circle would be any number greater than -1, but not including -1. We would need a closed circle, which corresponds to that greater than or equal to over there. So that would be our graph on a number line. For interval notation, when we write interval notation, it's always left to right. What's the leftmost number that we have shaded on this graph? Well, that would be this number. -1 is the leftmost number for this shaded region. And what's the rightmost number? Well, this arrow is going to infinity. So when we write interval notation, we're going to write it as a number, comma, a number. So our number is -1, comma, infinity. And then finally, with the notation that we use, if we have a closed circle corresponds to a bracket. And infinity, you can never really get to infinity. So a bracket represents like including that number. Since we can't include or arrive at infinity, as far as I know, we would have a parenthesis for the interval. And then x is less than 2. We would sketch that graph. We put 2 on the number line. It's less than 2, so we're going this way and shading that part of the line. And we need an open circle at 2, since we're not equal to 2, just less than 2. And then the interval notation there would be, what's the leftmost number on our shaded graph here? Well, the leftmost is way over at -infinity, and then the rightmost number is 2. So our interval notation would be going left to right, -infinity, comma 2. We can never arrive at infinity or -infinity, so that always gets a parenthesis. And then 2, since it's an open circle, we would have a parenthesis at 2 as well. That should be familiar to you from yesterday's or the previous lesson. All that we're adding today are these compound inequalities. So if we have a compound inequality, going to have two numbers. We have greater than or equal to -1, here's -1, less than 2, here's 2, and we have greater than or equal to -1 is this way, And then less than 2 is an open circle and this way. And since it's an and, we want the intersection. Where do these two lines intersect? Well, it looks like they intersect everywhere inside here. So that graph would be the intersection for this compound inequality. And to write that again, we do the leftmost number, which is -1, and then the rightmost number is 2. So we have -1, comma 2. -1 has a equal to, a closed-in circle, so that would be a bracket. And 2 is a less than, not a less than or equal to, so we would have a parenthesis. So that would be our answer. Oftentimes with compound inequalities with an and, you don't have any infinity symbol, whereas the first two here we did have infinity symbols. Next we have an or compound inequality. So we'll do our number line. We'll put -1 on there like we did before. -1, it's right about here. And 2 is, say, right about there. We want greater than or equal to -1. That would be this way. Or we want x's less than 2. That would be this way. Now with an and inequality, remember with and inequalities, we wanted the intersection where they overlap. With or inequalities, we want any possible answer, anything that's shaded. So what's shaded? Well, we have all the numbers greater than -1 are all these numbers. And then what numbers are less than 2? That would be all these numbers. So it looks like with this compound inequality, with this or, we would have every possible number is either greater than -1 or less than 2. So think about it. Say -7. Is -7 greater than -1 or less than 2? Yeah, it's less than 2. What about 10? Is 10 greater than -1 or less than 2? Yeah, 10 is greater than -1. So with this compound inequality, this or inequality, we actually have every possible answer. We have -infinity all the way to +infinity. And they both get parentheses, not brackets, because infinity always gets parentheses. Let's see what happens on the next one. We have a compound inequality. Here's 3 and here's 11. We have less than 3. That would be this way. And we have greater than or equal to 11. That would be this way. And since it's an and inequality, we want the intersection. So where is the intersection? Well, they don't intersect. There is no, for this over here, there is no intersection. These lines don't overlap. There's no overlap. If there's no overlap, then there's no solution. No solution. So again, with a compound inequality, there is no number that is less than 3 and greater than 11 at the same time. Can you think of a number that's less than 3 and it's also greater than 11? There's no one number that works for both. All right, let's look at our last one here, just getting used to the notation. We have 3 again and 11. We have less than 3 is this way, and we have greater than or equal to 11, which is that way. Now this one is an or compound inequality. So you can pick a number and it has to work for one or the other. It doesn't have to work for both. So numbers less than 3, those are all these numbers. Numbers greater than or equal to 11, that's all these numbers. And it could be one or the other, but it doesn't have to apply. The number doesn't have to be true for both. So for instance, like -7, -7 is less than 3. It doesn't matter that it's not also greater than 11. It just has to be one or the other. So the way that we would write the interval notation, we would do going left to right. So this is -infinity to 3. And we would have a parenthesis around the -infinity and a parenthesis around the 3. Or is a union 11 to positive infinity. And 11 gets a bracket because it's a closed circle, and infinity gets a parenthesis. So the most common ones that you'll see, the most common ones are ones that look like this and look like this. I gave you the two in between, those two bluish looking dots, aqua looking dots, just to show you what happens in certain cases. That's not very common, so you can be looking for answers will look either like this typically or like this typically. Not all the time, but most of the time, one of those. So let's use what we've learned to answer a couple questions. We'll work on number 1 and number 2 together, and then you can work on 3 and 4 as a try this. So the directions say solve the inequality, graph the solution set on a number line, describe the solution in interval notation. So the first one we have a OR compound inequality. And the solving itself is pretty easy. We get y, we're going to add 3 to both sides. 3 plus 1 is 4. And then subtract 2 from both sides, we get y is less than 1 minus 2 is negative 1. So to graph this on a number line, we would have negative 1 is on the left of 4. They're both open circles, and you want greater than 4 and less than negative 1. So this would be our graph of our solution. And then the interval notation would look like this. We're going to go negative infinity to negative 1. Or, which is a union, 4 to infinity. 4 to infinity. Again, we always go left to right when we label these numbers. Negative infinity is to the left of negative 1. 4 is to the left of infinity. So that's our answer. Let's look at number 2. Number 2, notice that we have 2 inequalities. We have 2 inequalities like that. We can separate them by writing 13 is less than 2x plus 7. And then that 2x plus 7 is less than or equal to 17. I'll show you a second approach in a second, but solve both of those, and we get subtract 7 from both sides. That would be a 6 is less than 2x. And then on the divide by 2, so we get 3 is less than x. If we flip that, that would be x is greater than 3. If you're flipping sides, you have to flip the inequality sign. And then subtract 7 on the right side, subtract 7 from both sides. So that would be 2x is less than or equal to 10. So x is less than or equal to 5. So is this an and or an or? Well, when you have the quantity, this 2x plus 7, in between these two less than or equal to signs, that would be an and. So the graph of our solution set, here's 3, here's 5, greater than 3 would be this way, less than or equal to 5 would be this way, and the and, or the overlap, the intersection, would be everything in between. So every number in between 3 and 5 would be a solution. So like 4 is greater than 3 and it's less than 5. Any number between 3 and 5 would satisfy both. And then to write the interval notation, going left to right, we go 3 is on the left, 5 is on the right. So we want 3 comma 5, where 3 gets a parenthesis and 5 gets a bracket. So this would be our interval notation, and this would be our the graph of our solution set. There's another approach I mentioned. Don't have a lot of space, but maybe I'll just erase and show you a different approach that you could have used. Let's erase with this option. Another approach that you might have thought about using is this approach. rather than rewriting it as two separate equations with the inequality here and here, another approach you could use is just subtract 7 from the middle, the left, and the right. So that would be 6 is less than 2x is less than or equal to 10. And then you divide by 2 in the middle, the right, and the left. So that would be 3 is less than x is less than or equal to 5. So this shows you that x has to be between 3 and 5. And that matches what we had here for our interval as well as our graph. So that's another approach that you could use. That will end the first video. Number 3 and number 4 are circled, so those are for you on the Try This 1.6. After you finish both videos, you can try those questions. Thanks for watching, and I'll see you in the next video.